All right, in this video, we're going to be talking about simplifying algebraic expressions, and that's taking these expressions that we have and writing them in a much simpler way. There's a lot of information in this video, so it's going to get kind of long. So if you want to take this video in chunks, that's okay, because I am going to separate it into several different concepts. So it says sometimes algebraic expressions can involve a lot of variables and numbers. It's helpful to be able to simplify these expressions to make them easier to work with or to understand. In order to simplify algebraic expressions, we must understand the parts that make up expressions. Now, these parts right here are going to be the things that I'm talking about: terms, variables, coefficients, and constants. Now, we've already talked about variables in the past, so I'm not going to spend time talking about variables, but I am going to talk about terms, coefficients, and constants first. So these are going to be the concepts that we're going to be using as these basic parts of algebraic expressions. So I'm going to start with a term. The most basic part of an expression is called a term. It's kind of like the building block of an expression. I think of terms like those little wooden blocks maybe you used to play with when you were a kid that had letters of the alphabet on them or numbers, and you could put them together and kind of link them together to form words or numbers and things like that. Every term in an expression is like a building block. You can hook them together to make larger algebraic expression. So a term is any numbers or variables that are separated by addition or subtraction in an expression. So if we look at this expression that I have here, for example, 3x plus 4 minus h, there are 3 terms in this expression, and you can think of each term as a building block of the expression like I have here. So I kind of put them in those blocks like I was talking about, the little wooden blocks. The first term is 3x. And then it's hooked to the second term with addition, plus 4. And then it's hooked to the third term with subtraction, minus h. 3x plus 4 minus h. These are 3 different terms to make our algebraic expression. Now, I always include the operation that's in front of the term with it, because that's what's happening, okay? The 4 is being added. We are adding 4. So the addition goes with the 4. We are taking away h. So the subtraction goes with the h. We're not taking away 3x, or we're not adding 3x. So the operation goes with the term that's right behind it. So include the sign in front of each number. Okay? Whenever you see addition or subtraction, that's going to be your tip-off that we have terms. So that's the first thing we need to get straight. So let's try a few examples here. See if you can identify how many terms are in each of these expressions, and we're going to put a box around each term like in the example that we just did on the other screen. So if you could pause the video and just go through these examples to see if you can determine how many terms are in each expression, I'm going to go through them right now. 5f plus 9. There are 2 terms in this expression, and 5f is the first term. Now, this is multiplication. Multiplication does not separate terms, only addition and subtraction. So the 5f, they go together. That's one block, that's one term. And then the plus 9 is another term right there. The next one, 23 minus 6 plus 12, this expression as written has 3 terms in it. 23 minus 6 plus 12. 3 terms, 3 things going on in this expression. The next one, 9n. Again, that's multiplication, so this is just one single term. There's only one term here. Sorry, I should have been numbered these. 2 terms, 1, 2, 3 terms. 1 term here. The next one, a plus 4b minus 3c plus 8. There are actually 4 terms in this expression. The first one being a plus 4b minus 3c plus 8. 1, 2, 3, 4 terms. And then c plus c plus c plus c. Again, there are 4 terms in this expression, and they are all the same thing. C plus c plus c plus c. 1, 2, 3, 4 terms. Now that is the absolute introductory level of algebraic expressions that you have to be able to do. You have to be able to identify how many terms there are in an expression to be able to simplify them. Next, we're going to talk about coefficients. Some terms and expressions contain variables, and remember, those are the letters that we have in our expressions, and these variables are multiplied by a number. That number is called the coefficient. So a coefficient is a fancy word for the number that's being multiplied by a variable. So if we look at this expression, 5x plus 7, this expression has two terms, but only one of the terms has a variable. What is the variable being multiplied by? Well, the variable is x. So this is our variable. We already know what one of those is. And x is being multiplied by 5. So we say 5 is the coefficient, not 5x, just 5. 5 is the coefficient. So coefficients, again, are simple concepts here with a big fancy word. So it's the number that's being multiplied by the variable. So again, let's try it. Let's apply what we've learned so far. Let's draw a box around each term. Again, we're going to identify the terms and then identify how many terms have a variable, and if they have a variable, what is the coefficient? So now we've got terms, we've got variables, and we've got coefficients going on in our expressions. So if you could pause the video and see if you could do that for these 5 expressions, as I'm going to go through them right now. The first one, 4c, there is only one term here, so I'm going to put a box around it. It does contain a variable. The variable is right there, and the coefficient is 4. 4 is the coefficient, c is the variable, 4c is one term. The next one, we have 7 plus 9k. 7 and plus 9k are the two terms. We have two terms here. The first term does not contain a variable, so 7 is not a coefficient. But the second term does contain a variable. The variable is k, and the coefficient is 9. Okay, so 9 is being multiplied by k. We call 9 the coefficient. Again, 7 is not a coefficient. That's something different. We're going to get to that in a second. The next one, 2t minus 4y. We have two terms, 2t and minus 4y. Both of the terms contain a variable. In the first expression, the first term t is the variable. In the second term, y is the variable. And then the coefficients, the first one is 2. The second one is 4, or sometimes we might refer to that as a negative 4 since there's a minus sign in front of it. The next one, 5z plus 32 minus 8y. There are 3 terms in this expression, 5z plus 32 minus 8y. Only 2 of these terms contain variables. The first term contains a z, and the third term contains a y. Those are our variables, so then they have coefficients. The coefficient of the first term is 5. And the coefficient of the third term is 8, or negative 8, we could say. 32 is not a coefficient because there is not a variable in that term. And then the last one, 2n plus m, there are 2 terms in this expression, 2n and plus m. They both contain a variable. N is the variable in the first term, and m is the variable in the second term. So what are the coefficients in this expression? The coefficient of the first term is 2, but what is the coefficient of the m? Now, some might say 0 because there's nothing in front of it. Some might even say the plus sign is the coefficient, but there actually is a coefficient here, and it is not 0. It is actually an invisible 1. There's like a 1 in front because it's 1m, and since it's 1m, we assume it's 1m, so we don't have to put a 1 in front of any variable when 1 is the coefficient. So that is something to remember. If a variable does not have a number in front of it, the coefficient is 1. You must remember that. Do not forget that a coefficient exists in front of every variable. And if there's not a number there, the coefficient is a 1. And that is coefficients. Now, next I'm going to talk about constants. Some terms do not have a variable, and we saw that in the last slide. These terms are just plain old numbers. We call these terms constants. A constant is any term that does not contain a variable. It's just a regular old, plain old number. So again, we're going to look at some algebraic expressions. We're going to find out how many terms there are, identify the terms, and then identify which terms are constants. Okay, so if you want to pause the video and do that, I'm going to explain that right now. Negative 9c plus 4 has 2 terms, negative 9c and plus 4. The first term contains a variable, so that is not a constant, but the second term does not have a variable, so that is a constant. The 4 is the constant in this expression. Next one, 7 plus 6v minus 9. There are 3 terms in this expression, 7 plus 6v minus 9. The second term contains a variable, so that is not a constant. However, the other 2 terms are constants, 7 and the negative 9, or the 9. Those are the constants in this expression. Next one, g plus h. This has 2 terms, g and plus h. They both contain a variable, so there are no constants in that expression at all. Next one, 3 plus 5 minus 9. 3 plus 5 minus 9. There are 3 terms, and they are all constants. Constant, constant, constant. There are no variables in there whatsoever. That's better known as a numerical expression. And then the last one here, we've got oodles of terms. We've got 1, 2, 3, 4, 5, 6 terms, and 3 of them contain variables and 4 of them do not. So we can identify our constants here. 5 is a constant, 4 is a constant, and that negative 7 or the minus 7 is a constant as well. So we have all of our basic building blocks of our algebraic expressions. We have terms, we have coefficients, variables, and constants. These are all the building blocks of an algebraic expression. You're not going to find anything else in an algebraic expression besides these basic things. So now we can go on and identify special types of terms called like terms. Because now that we're familiar with the parts of the expressions, we can begin to work on simplifying them, and some terms fit together because they're the same kind of term. We call these like terms because they are alike in some way. Actually, they have to be alike in a very specific way. Like terms are 2 or more terms that have the same variable, or it's 2 or more terms that are constants. So all constants belong together. They're all the same type of term. And all terms that have the same variable are like terms. They belong together. Okay, so they're all part of a group, and we want to collect those and put those together. So we need to identify the terms that are alike in either their variable or if they're constants. So if we look at 2x plus 3x minus 7, we have 3 terms, again, in this expression, 2x plus 3x and minus 7. Now these are like terms. The 2x and the 3x are like terms because they have the same variable, x. They're both boxes that contain x's. There are 2 x's in the first box. There are 3 more x's in the second box. They belong together. So we can actually collect those and put those together. The third term is a constant. So it is not a like term with the first 2. So it does not go with the x's. It does not belong with the x's. It is just a constant. So like terms and identifying them. So let's take a look at this expression and see if we can identify any of the like terms if there are any. So the first thing I want to do is identify what the terms are. I have a 4 plus 12y minus 8 plus x plus 9y. So there are 5 terms in this expression. Do any of these terms belong together? Actually, there are some that do belong together. The 4 and the minus 8 or the negative 8 belong together because they are constants. These are like terms. They go together. And also we have the y's, the terms that contain the y's, the plus 12y or the positive 12y plus 9y. Those go together because they both contain y's. And then we've got this guy right here, the plus x, that doesn't belong with any of them. It doesn't go with any of them, and that's okay. Sometimes there just aren't like terms in an expression, and it's okay to leave one out. So now that we know all of that, we can now finally get to the process of simplifying these algebraic expressions once we understand all the basic parts. So to simplify an algebraic expression, we want to do the following steps. The first thing we want to do is identify all the terms, and that's what we've been doing by drawing boxes around all of them. And then we want to combine all the like terms that have the same variables. So we want to look for terms that have the same variables and then combine them. And then we want to combine all the like terms that are constants, find all the constants and combine them. And then finally, write the simplified expression. So let's take a look at some expressions here and see if we can simplify these and write them in a simpler way. This first one is 4x plus 3x. The first thing I want to do is identify the terms. which are 4x and plus 3x. And then are they like terms? Do they belong together? Yes, they do. These terms go together because they both contain an x. So what I'm going to do is I'm going to combine them. So how do I combine them? I just pay attention to the operations that are going on in these boxes. I have 4 x's in this first box, and I'm adding 3 x's in the second box. So 4 x's plus 3 x's give me a total of 7 x's, and that's simplified. Okay, 4x plus 3x is 7x. So now that's a much simpler way to write that. I've gone from 2 terms down to 1 term. That's a simpler version. These are equivalent expressions. Next one, 9y minus 4y plus 7. I have 3 terms in this expression, and the y terms are like terms. I'm going to link them together. So now I have 9 y's in the first term, and I'm taking away 4 y's in the second one. That's why I include that sign in front. So 9y minus 4y is going to leave me 5y, and then this does not have any like terms, so it just gets copied, plus 7. That's why I include that operation in front, so I know how to write that in my simplified expression. So now we went from 3 terms down to 2. This is a simpler version. 5y plus 7 is an equivalent expression. Next one, 9 minus 8 plus 7g. These first 2 terms, again, are like terms because they're both constants, so they belong together. I'm going to put those together. 9 minus 8 is 1. And then this guy does not have any like terms, so it just gets recopied, plus 7g. 1 plus 7g is simplified because I have no more like terms, so now I, again, have gone from 3 terms down to 2. Next one, b plus 4b. There are 2 terms in this expression, b and plus 4b. These are like terms because they both contain a b. And remember that coefficient is a 1. There's a 1 in front of that b. So I have 1b plus 4b's. That gives me 5b. This is simplified because I've gone from 2 terms down to 1 term. Next one, I have 2x plus 5 minus 4x plus 10. So I have 4 different terms here. The x's actually belong together. These are like terms. So I have 2 x's in the first box, and I'm taking away 4 x's in the second box. Again, I can't stress the importance of that sign in front. That tells me what to do when I'm combining my like terms. The operation in front of the term tells me what to do with that term. So this plus sign right here behind the 2x has nothing to do with the 4x. So I'm going to include the sign in front so that I know what to do with my like terms. And 2 x's minus 4 x's actually gives me negative 2 x's, and then I have some constants here that are like terms. Plus 5, which is like, I can think of that as like a positive 5, plus 10. So 5 plus 10 is a positive 15, so I'm going to put plus 15. Since my term ended up being positive, I'm going to put a plus sign in front of it. And that is simplified. We went from 4 terms down to 2. And these 2 terms that remain are not like terms, so I know I'm done and I'm simplified. Last one, we have 12w minus 5 plus 6 plus negative 3w. And again, my w's are like terms, so I'm going to combine those. 12w plus negative 3w, that's like 12w minus 3w, and that is 9w. And then I have some constants here, and now that minus sign in front, I'm going to treat that like it's a negative 5 because I'm taking 5 away and then adding 6. So that's like negative 5 plus 6, which is a positive 1. And since my term ended up positive, I'm going to put a plus sign, plus 1. Now, if that had turned out negative, I would have put subtraction there. So 9w plus 1. And these are not like terms because 1 is a constant and 1 contains a variable. So that is simplified. And that's basically what we're doing when we simplify expressions, is we're collecting those like terms. So finally, let's look at algebraic expressions that contain parentheses. These get a little bit more complex, but we're going to apply what we learned in the last video about the distributive property to help simplify these expressions. So again, this first one, 5 times n plus 8, we can't do n plus 8. Those are not like terms, but I can use the distributive property to simplify this. 5 times n is 5n plus 5 times 8, which is 40, and these are not like terms, so that is simplified. 5n plus 40 would be another way to write that. Next one, 12 times b minus 3. b minus 3 I cannot simplify. Those are not like terms, but I can use the distributive property. 12 times b is 12b. Minus 12 times 3 is 36. These are not like terms, so that is considered simplified. I have eliminated the parentheses. It's a little simpler expression without parentheses. Next one, negative 2 times r plus 8. Again, I cannot do r plus 8. Those are not like terms, so I do negative 2 times r, which is negative 2r, plus negative 2 times 8, which is negative 16. And technically I'm done here, but I want to clean this up. I do not like these double signs here. So this is equivalent to negative 2r minus 16. And I'm going to say that's simplified because that is a simpler way to write it than negative 2r plus a negative 16. So whenever you have that double sign there, make sure you simplify that, whether it's minus a negative or plus a negative. Next one, here we have parentheses again, but now we've got an extra term hanging out here. So I cannot combine my h's if one is in parentheses and one is outside of parentheses. So I have to use the distributive property to get rid of the parentheses first. 9 times 3 is 27 plus 9 times h, which is 9h, minus 5h just gets tacked on there. Now that the parentheses are gone, I can actually combine my like terms, which are these two terms, the plus 9h minus 5h, or the positive 9h minus 5h. So I have 27 plus 4h, because that ended up being a positive 4h. And these are not like terms, so that is in simplest form. Again, I've got parentheses here and another term. So this 8k is just going to get copied, and I'm going to take this 3, this positive 3, and multiply it by everything in the parentheses. And positive 3 times 5 is positive 15 minus 3 times 2k, which is 6k. And now I can combine my like terms here. 8k minus 6k is 2k. And then this is just a constant, so it just gets copied, plus 15. 2k plus 15, those are not like terms, so that is in simplest form. Last one here, we've got a lot going on, but again, my first priority is to get rid of those parentheses so I can put my x's together. I don't actually have 4 x's. I have 1/2 of 4 x's. So 1/2 times 4x is 2x, plus 1/2 times 8, which is 4, and then the rest of the expression just gets copied, plus 2x minus 9. And I do have like terms here. 2x plus 2x is 4x, and then I have constants here. Positive 4 minus 9. Positive 4 minus 9 is negative 5, so that's going to be subtraction. I'm taking 5 away. 4x minus 5. And those are not like terms, so that is simplified. That is a much simpler version of this expression right here. Much easier way to write that. So simplifying algebraic expressions, absolutely critical skill to have in algebra.